Hello everyone, welcome to Code and Learn. So now that we have done a small introduction to REST protocol, it's time to write the code for it. So let's begin. First, I'm going to create an internal directory where all our internal packages will live. Internal, inside it, I will create the RESP package. So a directory, and then inside it, resp.go. The first thing I'm going to do is create the type for different RESP data types. So for that, I'm just going to create a new Go type data type, which is based on the byte data type from Go. Next, I'm going to define the constants that represent different data types. Const, first we will have an array data type and value is equal to star. So any array data type will start with a star or asterisk. Then we will add bulk string data type is equal to $sign. When I'm using the single quotation mark, you will see the data type is a byte. So that's why we are able to represent it as data type, which is based off byte. Next, I will add one for error. An error starts with minus sign. Then we will have integer. Integer starts with a colon. Then the last one we will have is a simple string, which starts with a plus sign. Now next, I'm going to define a struct that will represent a RESP value. So type value is a struct. First thing we will have is the data type. So data type of type data type. We can just do type here. Then I will add a string field, which will be a string. So this will be used to represent bulk and simple strings. Then I will have integer, which will be based on int64. This will be used to store the integer values. Then we will have array. If this value is an array value, then this array will store all the values. So this is a slice of pointer to the values. Then I will have another field is null. This is used to represent null bulk string or null arrays, which is what Redis allows with the REST protocol. So that's all the data types and constants we require to implement the deserialization. Before we write the code for deserialization, I'm just going to create a function here, which will be read until carriage return line feed. It will take a reader. We are going to use buffer.reader or a buffer reader. As a return value, this will return a byte slice or an error if there's any error reading up to the carriage return line field. What this function will basically do is, if we have a RESP value, something like an integer \r\n, it will read this value here. So if there's other value like this, it will read up till here. So that's the role of this function. We will use it to deserialize data or get the portion of this data. I'm using a buffer reader because it has some methods which makes it easier to perform the operations. For example, I can read the line, that is the line or the data till a given value. For that, I will use reader.readBytes, and I want to read until we find a byte that represents \n. So if you see, read bytes read until the first occurrence of delimiter provided in the input and returns a byte slice. If error not is equal to nil, we will return the error, which is return nil fmt errorf read line bytes. Next thing we want to do is, since we are reading up till \n, we want to confirm that the data was terminated in \r and \n. So we will do if len is less than 2 or line get the second last byte. So we will do len -2 is not is equal to \r. We will return an error saying line has not been terminated correctly. So we'll say return nil fmt errorf line not terminated with expected terminator. Since I'm not really formatting the error, I can just do errors.new. In the end, if everything works out, we will return the data minus the carriage return line field or the terminator. For that, we will just do len line, so up till the last two values. So that's a simple function that we have implemented. Now let's move on and implement a function to deserialize integer values. So I will say func, let me scroll this up, func deserialize integer. Again, accepts a reader, which is buffer.reader, returns a value. So the parsed value or the deserialized value and an error if there was any error. Let's write an example of what the integer value could look like. So it will start with a colon 1, 2, 3, 4 \r\n. So first thing we need to do is get this data. The data type, that is the colon, is deserialized by a function calling deserialize integer. So we will have something like function deserialize, which will accept the reader io.reader. This is because the connection or the net.connection is a IO reader, and return a pointer to value or error. Inside, we will first create a buffer reader, dot new reader, pass in the IO reader, and from that we will do something like resp type error buffer reader dot read byte. That will return the first byte. If error not is equal to nil, we will return the error, that is return nil, and fmt errorf read resp first byte. Wrap the error. Otherwise, what we will do is we will do something like switch on the resp type, and we will have cases here that will do like case array. Instead of typecasting array into byte, what we can do is do like type or data type and cast it into our resp data type. This will work because the underlying data type is a byte. So here we will have something like deserialize array, then bulk string, similar deserialized stuff, integer, simple string, case error, and that's it. For now we will just do return nil nil. We will come back to this function later to fill in the cases. So the deserialized integer will be used here. Okay, back to the deserialized integer. First thing I need to do is d error, let us read the data or read until the terminator pass the reader. If error not is equal to nil, return the error. Nil fmt errorf read integer data. Wrap the error like this. This will return this here because again we are reading the colon in deserialize when we do read byte. So we will only be left with 1 2 3 4 when we do read until terminator or carry as return line field. Here I will say I, which represents the value I or error. We will use string con dot parse integer value, turn this into a string since it's a byte, typecast it to string, and use the base of 10 and the size of 64. If error not is equal to nil, we will return the error nil fmt errorf parse or deserialize integer value. Otherwise, we have successfully deserialized the integer value from the resp data into our type. So we'll just do return pointer to value. Since this is an integer, we will say integer is equal to I, type is equal to integer, and nil for error. So that's a simple deserialize integer function. We can use this here and just do return deserialize integer, supply the reader which is prd, and that's it. Just to make things consistent, I'm just going to rename this to rd or reader. Next, let us implement a deserialization function for a simple string. Func deserialize simple string. Again, accept the buffer.reader returns a pointer to value or error. Again, read the string data. So this is what a string or a simple string would look like. Starts with plus, which should be read and deserialized when we do read byte, and then we need to get this part of the data. So we will do d error read until crlf pass the reader. If error is not is equal to nil, return the error nil fmt errorf read simple string data. Wrap the error. Otherwise, we should have the data, so we can simply return the data. Pointer to a value, type is simple string, and the value is string, which is typecast the byte to string, and nil for error. So that's a simple function for deserialize simple string. I can do again return deserialize simple string, pass the reader. Similar to this, we will next implement deserialize error. So we can do func deserialize error, which takes a reader. Again, buffer.reader returns a pointer to the value or an error if there's any. Again, d.error read until terminator provide the reader. If error not is equal to nil, we say return nil fmt errorf read error data. Otherwise, we should have the data, and we can return pointer to the value and nil for error. Inside it, we will say type is error and the string or the error string is equal to string data or d. Let me add a comment here to represent the example. So example, and that's it. So we can now use this in this or the error case. Return deserialize error, pass in the buffer reader. Now we need to implement one for array and bulk string. First, let us go and write the function for decoding or deserialization of a bulk string. Deserialize bulk string takes a reader, value error, read the data, read until terminator. We will pass the reader. If error not is equal to nil, similar to other functions, we will do return nil fmt errorf read bulk string data, and then we will wrap the error with %w. Now things are a little different for bulk string. They're not as simple as the simple string or integer values. Here is an example. So we will start with the length of the bulk string. So here, this should be the length of the bulk string, that is 5, because we are reading until the first terminator, that is this here. So let's convert this into an integer value. So we will say string length or bulk string length error, again string con parse integer, typecast the data into a string, 10 for the base and 64 for the size. If error not is equal to nil, we will say return nil fmt errorf or parse string length, and we can wrap the error. So now if we have the string length, we need to check if string length is -1, which is used to represent a null bulk string. So we'll say if string length is equal to -1, that is, we have a null bulk string here. This is used in special cases, which we will look at later. For now, we will just do return value type bulk string value. We don't need to use the string value. We can use is null is equal to true and return nil for error. If string length is not is equal to -1, that means we have a valid string. So something like hello. Now to read the next byte up to the string length, we will use a byte slice. So I will say string bytes is a byte slice of length string length. Now since we have the reader, what we can use is read len error io dot read full reader and the string bytes. So read full reads the exact length of the provided buffer. So we should be able to read the data up to the given length. So this hello here, we should be able to read it. If there is any error, we return the error. Return nil fmt errorf read bulk string. Wrap the error. Now why did we initialize the read length variable here? Because read full will return the number of bytes read from the reader. So we are using this to confirm that the read length is equal to the actual length we expect. So if read length is not equal to the length we expected, we will return nil fmt errorf saying short bulk string. So there's corruption of data expected %d code %d first string length and then read length. Now the next piece of data should be the actual bulk string. That is, this should have the actual bulk string at this point because we read it full up to the length from the reader. So we can do return value type, which is bulk string, and the value should be string. We can do typecasting and do string bytes, nil for the error. Now the important thing to note here is before returning this, we need to read off the trailing \r\n, which is used to represent a bulk string or the end of the bulk string. So we'll do carry as return line field. Again, we will use the same method, that is make a byte slice of 2 number of bytes read and error io.read full, pass the reader or RD and the buffer we created to read the terminator. If n is not equal to 2, so we expect 2 bytes to be there, that is to represent \r and \n, or error not is equal to nil. Let me move the error not is equal to nil to the first condition so that we can return early. Here I will just use if the first character in the read value is not is equal to \r, or the second byte is not is equal to \n, it wasn't terminated correctly. So we can just say return nil fmt errorf bulk string not terminated correctly and use the read data. You just need to fix this because this should be not is equal to. And that's it for deserialization of the bulk string. First, we read the string length using read until terminator or read until carry at return line feed. Then we parse the string length. If string length is -1, we return the bulk string as a null bulk string. Then we read the string bytes. We use the string length to read the string bytes. Then we compare if the data read or if the number of bytes read is not equal to the string length or the length of the bulk string sent to us, we return an error. Otherwise, we read off the carry as return line feed of the bulk string and then return the bulk string. So here we can just do return read deserialize bulk string, pass in the reader or the buffer reader. Now the last thing we need to implement is deserialization of an array value. Let's do that. Here I will create a function deserialize array takes a reader, again buffer dot reader value error Here we have an example of a array value represented as a RESP value. So we see here it starts with the asterisk, which should be read off in the deserialize function. Then we have the terminator. Then we have the number of elements in the array. So let's first read that. The error read until carriage return line field, pass in the reader. If error not is equal to nil, return the error, that is nil fmt errorf read num elements. Wrap the error. Otherwise, we will use parse int again to parse the number of elements. So we can say n error string conf dot parse int, pass in the value, again typecast it into a string, base 10, size 64. If error not is equal to nil, we return nil fmt errorf parse the number of elements or num elements. Now an array could be null too, so we will check if n is equal to -1. Similar to the bulk string, we will do value type array is null is equal to true. Return nil for the error. Otherwise, we need to read off the next elements. Let's create a array or a slice of values. Capacity is n. That is the number of elements that we were told by the REST protocol exist in this array. Now let's range through n. For I, range n, array I, error. So we will recursively deserialize the values. That is, we are using this function again to deserialize the array elements. For example, once we are done reading the length, we get up to this here, which is $, or a bulk string, $5, terminator, hello, and terminator again. So we will just use the main deserialize function to read off this bulk string. If error not is equal to nil, return nil fmt errorf deserialize array element. I just need to remove this from here. After this, we should have the complete deserialized array. So we can do return value type array, and the array itself is the array we created here, and nil for the error. So that's the last bit here. We can do return deserialize array and pass in the reader, that is buff your reader. So that's basically our deserialize function, which based on the RESP type processes the data and calls a relevant deserialize function. We need to add a default case here. So we will do default. If RESP type is invalid, we will just do return fmt errorf unknown RESP type. So that's all the deserialization logic. I will encourage you to write the test for deserialize to make sure that everything is working as expected. If you don't know how to write these tests, please refer to the code for this lesson and you can find the test for this. In the next lesson, we will implement the reverse logic, that is to serialize the value type into RESP data that we can send on the wire. Just to revise, in this video, we went through deserialization of RESP data. First, we created a value type inside the RESP package to represent the RESP value that we get over the line or over the connection into a Golang value. Then we implemented different functions like deserialization of integers, error, bulk string, etc. to deserialize the provided data into the Golang type that we created. So the next video will be about converting the Golang value that we have here into the RESP type. Again, give it a go at writing the test for these functions. I will see you in the next video. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.